All right, so hyperbolas. We already kind of looked at the shape on the very first day that we started talking about conic sections. Remember, it's created by the cone on top of the inverted cone, and cutting perpendicular to the plane, you end up with two essentially parabola-looking shapes. It's got a lot more going on than any of the other conic sections that we have done. Because it has two pieces there, it has what we consider asymptotes. Okay, remember from rational functions, we dealt with asymptotes. They're slant asymptotes in this case. But the good news is everything is symmetric. Okay, everything is symmetric when it comes down to a hyperbola. Just like it is with a circle, just like it is with an ellipse, you have symmetry. So you do have this picture in various places there on your paper. Let's go through what I've got on your notes there. And hyperbola is a set of points such that the difference of the distances from any point on the hyperbola to two fixed points remains constant, and those fixed points are the foci. So it's kind of like an ellipse, where we have the two foci, and the points on the ellipse were the sum of those two distances. For a hyperbola, it's the difference of those two distances. So d1 minus d2 remains constant for all points on the hyperbola. So when we subtract those two distances, we get the same number. So I could pick a point way down here, and if I measured that distance and that distance, if I subtract the two, I would get the same difference as when I subtract difference 1 and difference 2, okay? Or distance 1 and distance 2, excuse me. All right, so we've got horizontal, opens left and right, so same deal as with an ellipse. That would be with the x's. The vertical opens up and down. We have a center with this, just like we have a center with our ellipses and circles. We've got our vertices. Let's label some of this stuff. This is your center, obviously right here in the middle. Okay, that's your center. You've got a vertex, okay, these points that line up on the same line as the center are vertices. Your foci they're inside the curve, but they kind of look like they're on the outside, I guess you would say. I consider them inside the curve because of the way that it's curving, but those points out there are the foci. Technically, we have co-vertices as well. There's this little box that's created with a hyperbola, and so your co-vertices help create that box that's drawn there with those dashed lines. And then those slanted lines are, of course, the asymptotes. All right, so the center is the midpoint of the foci. That's a little different from the ellipse. I mean, technically, it's also the midpoint of the vertices because it's all symmetric, okay? So I'm going to put slash vertices because it's all symmetric. It really doesn't matter if it's in the middle of the foci or in the middle of the vertices. It's still in the middle, right? The asymptotes are the diagonal lines that, quote unquote, guide the curves. So if you have steeper asymptotes, your curve is going to be wider. If they're more shallow, if the asymptotes come more like right here, that curve's got to fit in between the asymptotes, so it's going to be a tighter curve there. The vertices, or this teacher refers to it as the turning points, are plus and minus a units from the center. So just like with ellipses, the vertices are plus and minus a units away from the center. The co-vertices are plus and minus b units away from the center. So again, just like your ellipses, so not really a new concept that we have to remember here. And the foci are, what do you think it's going to be? Plus or minus c. Units away from the center. This time, though, c squared is a squared plus b squared. Okay, this time c squared is a squared plus b squared, but that is one of the things that you are told on the formula sheet for the final exam. The ellipse, they give you c squared equals a squared minus b squared. For the hyperbola, they give you c squared equals a squared plus b squared. So they do give you that information. You don't have to remember which one's which. But I think an easy way to remember it is hyperbola has the h. It's got that cross right in the middle, so think of it kind of like a plus sign as opposed to the ellipse. It has all those just straight lines in a capital E, so it's minus. Random thing maybe to help you remember. So our standard form, it looks very, very, very similar to our ellipse equation, x minus h squared over a squared. Here's the difference, minus y minus k squared over b squared is equal to 1. Now, in this case, for hyperbolas, a is not always greater than b. A is not always greater than b. A is not always greater than b. That only applies to ellipses. What tells you the difference between horizontal versus vertical is which one is positive. It's which one is positive. So if the x comes first and the y follows the minus sign, then it's horizontal. If the y comes first and the x follows the minus sign, then it is vertical. All right, the equation for our asymptotes is y is equal to plus or minus, because we have one that has positive slope and one that has negative slope, b over a times x minus h plus k. So it's the y coefficient over the x coefficient there. Okay. And it's h and k just come from the center of the hyperbola, because if you look at the picture, those asymptotes, they go right through the center point. So that's where the h k comes from. If it's vertical, then that relationship is flipped. But it's still, notice, it's still y over the x. Y this time is over the a, x is over the b. So your slope is y over x, which makes sense, rise over run, right? Y over x, rise over run, and the rest of it is the same. So to graph our hyperbolas, obviously we need to be in standard form. We start by plotting the center, the vertices, the co-vertices. We use our formula to find our foci, and then graph the asymptotes is our last step. So let's look at graphing some of these. Let's look at number, number 6 first. Look at number 6. We have x squared minus 9y squared plus 10x is equal to negative 16. So it's not in standard form, but looking at my equation, I can already tell this is going to be horizontal, because the x is positive, the y is negative, the y squared is negative. So I know that this is going to be a horizontal hyperbola. Okay, so go ahead and make yourself a note of that. So when you start drawing it, you can get everything in the right place. So let's put it in standard form first. We got to go through our completing the square process, but we only have to do it with the x's because we don't have a linear y term. So if we divide 10 by 2, we get 5. We square 5, we get 25. So don't forget to add it to the other side. So we have x plus 5 squared minus 9y squared. Negative 16 plus 25 is 9. Remember, it's always got to be equal to 1, so we go through and divide everything by 9. So our standard form is x plus 5 squared over 9 minus y squared over, I really don't need it, but I'm going to put it there just because I've gotten a few questions about this. It helps you remember what your b value is going to be if you put that over 1 there. So that's our standard form, so we can go ahead and identify our center. Our center is negative 5, 0. Let's go ahead and plot that. 1, 2, 3, 4, 5. Negative 5, 0 is our center. We need to find our vertices. They are plus and minus a units away from the center. So a is always the first coefficient now. So a squared is equal to 9, so a is equal to 3. So we go 3 units in both directions horizontally from the center. So 1, 2, 3, 1, 2, 3. Those are our vertices. So that is at negative 8, 0, and negative 2, 0. Add and subtract 3 from the x. Our co-vertices are b units away from the center. So b squared is equal to 1, so b is equal to 1. So we go up 1 and down 1. They're very close from our center. So negative 5, positive 1, and negative 5, negative 1. Our foci. We got to figure out what c is. C squared, in this case, is equal to a squared plus b squared. Whoops, I used a and b instead of squared. A squared is 9, b squared is 1. So that's 10. So c is the square root of 10. Our foci are that many units on the same axis as our vertices, so we add and subtract the square root of 10 from the x coordinate of the center. The square root of 10 is a little bit greater than 3, so our foci are pretty close to our vertices. Are pretty close to the vertices. I don't think they're not even 1 unit. Let me check. Negative 5. Yeah, not even. It's really close to our vertices. Negative 8.16. Really close to vertices. All right, our asymptotes. Okay, our asymptotes are y equals plus or minus, it's going to be b over a, so 1 over 3, x minus the x coordinate of our center, plus the y coordinate of our center, which is 0, which doesn't do anything. So this is plus or minus 1/3 times x plus 5. I'm going to leave it that way, because if you look at the picture of these hyperbolas from the very beginning, look at where the asymptotes go through. If we were to draw that little box with the vertices and the co-vertices, then the asymptotes go through the corners of that box. So that's a really easy way to graph these asymptotes. Just go from your center and draw a dotted line. I know mine doesn't look very dotted, but a dotted line to the corner of your vertex and your co-vertex. Okay, where those would meet, go up from the vertex, go over from the co-vertex, and that's your slope. Go up 1 over 3, and you can keep going up 1 over 3. You can go in the other direction. Okay, that's one asymptote. Try to fit the other one in here. Okay, so here's an example of these asymptotes are pretty shallow. So our hyperbola is going to be very narrow. And we fit it in there. It just hugs the sides of the asymptotes there. And you make it look like a parabola. All right. Questions? Let's go ahead and look at an example of writing the equations. Let's look at an example of writing the equations, and then we can practice. Okay? So let's write it down one more time. If it's a horizontal hyperbola, it's x minus h squared over a squared minus y minus k squared over b squared is equal to 1. Vertical just flips it around. The y comes first. And the a and the b stay where they are on this one. Okay, the a and the b stay where they are. HK is our center. Okay, just reminding ourselves of what we've done already. Okay, HK is the center. A is the distance from the center to the vertices. B is the distance from the center to the co-vertices. Nothing new there, just writing it down again. All right, so if we've got our graph here, we want to write the equation. First thing that I want to identify, horizontal or vertical. So for number 1, is it horizontal or vertical? Which way are the curves opening? Up and down, so it's vertical. Okay, so this is vertical. What's our center? The origin, 0, 0. All right, so that means since it's vertical, my y comes first. Since it's 0, 0, I don't subtract anything. Same thing for the x, it's 0, 0, so I don't subtract anything. I got to figure out what a and b are. A is the distance from the center to the vertex. The vertex is on the curve, so that distance is 1, and I square it. A is the distance from the center to the co-vertices. They were nice and drew the little box in there, so we can see that's a distance of 4. So if we make this look a little bit better, they would just write it as y squared minus x squared over 16 is equal to 1. Okay. Well, how about if they give us some information instead of giving us the graph? Very, very, very similar process to what we did yesterday with ellipses. Find your center, it's in the middle. Okay, it's in the middle. And then you may need to find, it depends on what numbers you need from there. Okay, so let's look at, let's look at number 4. Let's look at number 4. They give us the vertices and the co-vertices. So the center is the middle of the vertices. So 4 plus 4 divided by 2, 8 plus -8 divided by 2. So that's 4, 0 is our center. So we can go ahead and fill in that part of our equation. We do need to figure out, though, whether it's vertical or horizontal. Okay, so the vertices are 4, 8, and 4, -8. So they're right above each other. So that's vertical. This is another vertical. Okay, 4, 8, 4, -8. They're right above each other. So it's just like the picture we just looked at. The vertices were above each other, and the co-vertices are beside each other. So y is going to go first. The center coordinate for the y is 0, so we're just going to leave it like that, minus x minus the x coordinate. We got to find a and b. Okay, we got to find a and b. So the distance between our vertices, we go from +8 to -8, so that's a distance of 16. Right, so that's the whole distance. A is just half of that, so half of that would be 8, and we square it. So 64 goes under our y squared. Okay, A is the distance from the center to one of our vertices. I should have phrased it that way. Okay, from the center to the vertices, from 4, 0 to 4, 8 is 8 units, and then we square it. Okay, from the center to our co-vertices. So from 4, 0 to 1, 0, that's a distance of 3. So that's our b, and then we square it to get 9. Let me write that down here. So when you look back at it, you know what we did. 4, 0 to 4, 8. So a equals 8. 4, 0 to 1, 0. B equals 3. Okay, so that's all we had to do. That's the equation. Questions about any of those pieces? Let's do one with the foci. So usually the last ones are the okay, let's look at number 12. Number 12. All right, so on number 12, they give us the co-vertices. Let me think through this for a second. Okay, yeah, that's good. Okay, so the co-vertices are -2, 0 and -2, 10. So the co-vertices are above each other. So that means the vertices are going to be across from each other. So this is a horizontal. Okay, this is a horizontal. Because the co-vertices are above each other, the vertices are going to be beside each other. When the vertices are beside each other, it's horizontal. Okay, so we know that our x is supposed to go first. Our x is supposed to go first. So let's find our center. Okay. Add the x's, divide by 2. Add the y's, divide by 2. So our center is -2, 5. Our x comes first. So x plus 2 squared minus y minus 5 squared equals 1. Now, we can find B with the information that we have right now, because B is the distance from the center to the co-vertices. So center, -2, 5, to one of the co-vertices, -2, 0. How many units? 5 units. So 5 is B. So the y minus 5 squared is over 25. Now, to find A, we don't know our vertices, we know our foci. Okay, we know our foci. So the foci are C units away from the center. So from the center to our foci, what have we done? We have added and subtracted the square root of 51. From the center to the foci, we've added and subtracted the square root of 51. So that's C. So that means C squared is just 51. And the formula for this one says C squared is equal to A squared plus B squared. So C squared is 51, A squared is what we're looking for, B is 5, so B squared is 25. So when we subtract, we get 26. Is A squared? We don't need to take the square root. We really don't need A. We just need A squared, because A squared is what goes into the equation. Because if you take the square root, you're just going to turn around and square it. So just leave it as A squared. Now, if you had to actually identify where the vertices were, then yes, you would need to take the square root of that. But for this, you just need to write the equation. Okay?